Okay, so for notes number 5, we're just gonna take a look at one problem. So a Ferris wheel that is 60 feet in diameter makes a revolution every 80 seconds. So 60 feet in diameter makes a revolution every 80 seconds. The center of the wheel is 35 above the ground, 35 feet above the ground. Find the equation in the form y equals a sine b x minus c plus d that models a rider's height off the ground while riding the Ferris wheel. Okay, so first I'm going to go ahead and draw a Ferris wheel. Some of you have probably written them before. Now we know that the diameter of this Ferris wheel is 60 feet, right? Well, that means that if the diameter is 60, we can also say that the radius of this Ferris wheel is going to be 30, because it's half. And it also tells us that the center of the wheel is 35 feet above the ground, right? Because the Ferris wheel is usually like propped up by something. And this whole thing here is 35 feet. From the center of the wheel all the way down here. So, you know, when people get onto the Ferris wheel, they walk up and they get into like the basket thing, and then it rotates around and so forth. And so we're going to go ahead and model what this looks like. So let's say that you are getting on this Ferris wheel. I'm going to go ahead and create a X and Y table. T represents seconds or time, and then H of T represents the height off the ground. So at time 0, which is the initial time, you walk up and you get into this basket here. Right, when you're in the first basket here, you are now 5 feet off the ground because it said from the center to the ground it was 35 feet, right? And then the radius of the Ferris wheel is 30. That means that this height right here has to be 5 feet, right? So if you walk up and you sit into the basket, you are 5 feet off the ground. Now it does tell us that the revolution is every 80 seconds. So that means at 80 seconds, you make one full rotation, and that means at 80 seconds, you're back to your starting position. So that means at 80 seconds, you are again 5 feet off the ground. Now, let's start off with half. So that means at time 40, you should be all the way at the very top of the Ferris wheel. So what would your height be? Well, we know that the diameter of the Ferris wheel is 60, and we know that the Ferris wheel is 5 feet above the ground. So if you're all the way up here, 60 plus 5 is 65. You are 65 feet above the ground. Let's break it down even more. Let's talk about 20 seconds. So if times 20 seconds, you should be right here now, right? And we want to figure out the height of this guy. Well, we know that the radius is 30 plus the 5 feet above the ground. So that means you are 35 feet above the ground. So don't forget to add this plus 5. And then let's go ahead. At 40 seconds, you're 65 feet. At 60 seconds, you're right here, which means that you should be the same height as this when you were at 20 seconds. So again, you should be at 35 feet. And then you're at 80 seconds again. And if you were to continue this, like at 100 seconds, if you're at 100 seconds, you should be right here again, which was 35. At 120 seconds, you'll be at the very top of the Ferris wheel, which is at 65. At 140 seconds, you should be 35 feet again. And then at 160, you're back down there. So let's go ahead and graph this to see what it looks like. Draw this a little bit bigger. So 20, 40, 60, 80, 100, 120, 140, 160. And our x-axis represents t, which is time, that's in seconds. Our y-axis is our height off the ground. And our lowest height is 5, our highest height is 65. So let's see here, 10, 20, let's scale up by 5s. And then I'm gonna go ahead and graph these points. So at 0, we are 5 seconds off the ground. At 20 seconds, we were 35 feet off the ground. At 40 seconds, we were 65 feet off the ground. At 60 seconds, we were 35 feet off the ground. And at 80 seconds, we were 5 feet off the ground. At 100, we were at 35. 120, we were at 65. 140, we were at 35. And then 160, we were at 5. And then, of course, you could find more points in between, but I just wanted to pick the easy ones. I'm going to go ahead and connect all these dots. So if you were a little skeptical of how this Ferris wheel problem is actually turned into a trig function, hopefully you are now more convinced that this actually is modeled by a trig function here. Okay, so let's go ahead and figure out what the equation of this graph is. And I actually want you to use sine, so the equation I want you to use is up here. So we're going to use sine, and we're going to go ahead and find all the different parameters of our graph here. So y equals a sine. There's a lot of parentheses here, so be careful. Remember the a is our amplitude. Our b we need to find using the period. The c is our phase shift. And then the d value is our midline. I always like starting off with the midline. I think that's easiest. So I feel like here the midline is right in the center of our graph. So I'm going to go ahead and draw a horizontal line there. We can see that our midline is at 35. So that means d equals 35. From there, I like to find the amplitude. So remember, we want to figure out what this height is, or you could even figure out what this height is. This top point right here is 65. This is 35. 65 minus 35 is 30. Same thing, even if you did it on here, 35. This point here is 5. 35 minus 5 is also 30. It should always line up. That means our a value is 30. Let's take a look at our b value here. So remember our infamous formula, t equals 2 pi over b. So if you look here, I'm going to go ahead and graph one full period. So you can see it different ways. Like you can see it from, I'm going to use the sine graph because we want to eventually use sine. Remember, sine starts at the midline, it goes up, it goes down, and then it ends up back on the midline. So we see here that it started at 20 and then it ended at 100. 100 minus 20 is 80, which makes sense because it also says that the revolution is 80 seconds. So because it takes 80 seconds to complete one cycle, that is the period, which is t. So we have 80 equals 2 pi over b. I'm going to go ahead and multiply by b to both sides. So I get 80b equals 2 pi. Divide by 80. Our b value is 2 pi over 80. We could simplify this a little bit more. A number that divides 2 and 80 is 2. So we have pi over 40. What we just found right here is our b value. Remember phase shift? Phase shift is when you set this whole parentheses equal to 0. So that's why this equation looks a little bit different. Typically, I used to just have bx minus c equals to 0. But you do want to figure out what that parentheses is equal to 0. So that's why we have a double parentheses there. It looks a little bit more confusing, but it means the same thing. So remember, when you're looking for phase shift, you want to set x minus c equal to 0, right? If you look here, this is the start of my sine graph. So we do have a phase shift to the right. And if you look here, typically our sine graph starts like this, right? It starts at 0, 0, or it starts on the y-axis. So if you look here, it doesn't start on the y-axis, but it's shifted to the right, and we see that the phase shift is 20. So because it is to the right, it has to be positive, so that means c equals 20. And then we're just about done. We're just going to go ahead and write down our final answer. Our final answer is y equals 30 sine parentheses pi over 40 other parentheses x minus 20 close double parentheses plus 35. This right here is your final answer, and that is it.